Hi everybody, today I have a quick video on piecewise functions. So piecewise functions are simply functions that have multiple pieces. So some functions don't have like the same price for every item, like movie tickets. So think about when you go to the movies, a lot of times they give you the price based on kind of who you are. So are you an adult, are you a child, or you're a senior? And you can see there's a different price based on who you are in this case. This can also happen when you go shopping, and there's different ways this can happen. So this particular site says you're going to pay based on how many items you buy, and their minimum is 12. So let's just take a particular example and say we decided we were going to buy 24 hats. So looking at the cost, it says, okay, for 12 or more, but not 25, you're going to pay $5.39 each. So if we do 24 times 5.39, that's equal to 129.36. Let's do the same thing, but now let's buy 26 hats. So this particular site says, okay, for 26, you're going to pay $4.90 per hat, which is 127.40. So it was actually cheaper to buy 26 hats than to buy 24, so kind of like this bulk buying. Now, this doesn't always happen. You have a project that we will talk about in a second video that doesn't do this, where you're going to pay that same price for the first so many and then you pay another price for the next so many, and I have a second video that will talk about that. But this is just to introduce us to the idea of piecewise functions. So let's look at what that would look like if we wrote it out. So this is what the function would look like, and we have multiple functions, so this is the first one I'm starting with. So I have f of x equals x plus 3 if x is less than 6, and it's 2x if x is greater than or equal to 6. So we're going to evaluate f of 2. So how do I start? I look at, well, where is 2? Is 2 less than 6 or is it greater than 6? And because it's less than 6, I'm going to do what it says. I'm going to do this first line. So 2 being less than 6 says, hey, add 3. So I have 2 plus 3, which is equal to 5. The next one says, okay, f is 6. So when I look, this says less than, this says greater than or equal to. That equal to tells me I should use the second line. So I'm going to do 2 times 6 is 12. The last one says 15. So I look at, what is 15? Is 15 less than 6? No, it's greater than or equal to 6. So I want to use the second line again and do 2 times 15, which is equal to 30. So the numbers on the right tell me if I should use the first line, the second line, and eventually we'll get a third line. So here's one with 3 lines. This one says f of x is equal to 2x if x is less than 3. It's x minus 4 if x is greater than 3 but less than 7. And then it's the square root of x plus 2 if x is greater than 7. So I'm going to start with 14 and I look. Is 14 less than 3? No. Is it between 3 and 7? No. Is it greater than 7? Yes. So I'm going to do the square root of 14 plus 2. That's the square root of 16, which is 4. So let's try the next one. It says negative 1. So I go, is negative 1 less than 3? Absolutely. So I'm going to do 2 times negative 1, which gives me negative 2. My last one, 5. I look, is it less than 3? No. Is it between 3 and 7? Yes. So I'm going to do 5 minus 4, which is 1. Notice I have one number I put in. I have one number I get out. So the beginning number x, I'm using the x's to decide which line I should use, and then whatever answer I get out is the answer I get out. I don't have to do anything with that. I don't look back at the function. I just go, okay, I got my work. Let's go to the next one. So here's another example. I have f of x is 2x if x is less than 3. It's the absolute value of x minus 9 plus 2 if x is greater than or equal to 3 and less than 7. And then the square root of x plus 2 if x is greater than or equal to 7. So I'm going to start with 0. So first look at where is 0? First line, second line, third line. Hopefully you said, oh, it's the first line. So I'm going to do 2 times 0 is 0. Then I look at 3. Now with 3, notice it's kind of one of the boundary numbers. I see it in the first line, I see it in the second line, but I really care about that equality. The equality makes a big difference. So I'm using the second line, absolute value of 3 minus 9 plus 2. So let's do that in steps. 3 minus 9 is negative 6. So I have the absolute value of negative 6 plus 2. Remember, absolute value just says make it positive. So absolute value of negative 6 is 6. 6 plus 2 is 8. The next one I have is 5. 5, when I look through, I'm still in the second line. So once again, I have absolute value. I have 5 minus 9 plus 2. 5 minus 9 is negative 4. So I have the absolute value of negative 4 plus 2. Absolute value of negative 4 is 4. 4 plus 2 is 6. The third line says I should do the square root of 7 plus 2. Square root of 7 plus 2 is the square root of 9, so my answer is 3. Again, one number in, one number out. We can also talk about the domain, saying like what numbers are we evaluating for a particular function. So what I want to look for is kind of like, does it line up? So see how this says less than 18? So I know like if I looked on a number line, okay, I have everything less than 18, but then it picks up at 18 and it keeps going. So that says all numbers are defined for this particular function. So this domain would be negative infinity to infinity. And you know, Mobius a lot of times will make you write something like the word infinity. So like negative infinity to infinity. Let me just throw one more on there to say, could that look different? So maybe I have something like x plus 2 if x is less than 4, and then x squared if x is greater than 4. What's missing this time is nothing says x equal 4. So this time, if I were to talk about the domain, I would go from negative infinity until 4. And then I would also go from 4 to infinity. So I wouldn't want to have square brackets. I would want to have open brackets to say I am missing that 4. I have things less than 4, I have greater than 4, but I don't have equal to 4. So lastly, I just want to quickly show you graphs of piecewise functions. And again, they're going to have pieces. Sometimes the pieces will touch, other times you will see jumps in the graph. So let's try graphing some on our own. So I tried to start really easy. I have f of x is negative 2 if x is less than or equal to 3. And then I have 4 if x is greater than 3. What I really see is with the f of x equals negative 2 is like y equals negative 2. So this is a horizontal line that's going to stop when I get to x equal to 3. Right, so when I look at y equals negative 2, I go down to negative 2 on the y-axis, and it says this is going to stop at 3. So I'm going to put a dot at 3, and it's closed in, so it says equal. And then any number that's less than 3, I'm just going to have this horizontal line there. Now the second part says y is equal to 4, so again a horizontal line, so I know I go up on the y-axis to 4, and this is going to start at 3, so I'm going to do an open circle. That open shows me that it doesn't include at 3, and then this is going to go to the right. So see this jump, I have two pieces to the graph, one when I'm less than or equal to 3, one when I'm greater than 3. So let's try again. This one's a little bit bigger. I have x plus 2 when x is less than 1. I have 4 when I'm between 1 and 3. And then I have x squared when x is greater than 3. So let's start with this x being less than 1. I have this like y equals x plus 2. So what I would do is I would still plug in 1 and just make it open. So 1 plus 2 is 3. So when I look at the point 1, 3, I'm going to do an open circle. Then I want to get some numbers like on the left of 1. So let's pick something smaller like 0. So 0 plus 2 gives me 2. So I could plot that point. Maybe you want to do negative 1 plus 2, which is 1. So let's plot that point. And you can connect the dots and you have this nice little line. Then where it says f of x is 4 between 1 and 3, so that's back to a horizontal line like y equals 4. Starting at 1, but again open because it doesn't say greater than or equal to, it just says x is greater than 1. And this is going to go to 3 where it's going to have another open circle. So 2 open circles to show that just strict inequality that I don't have less than or equal to. Then the final one is at 3 and it says x squared. So again, let's do 3 squared, which is 9. So I'm going to go over to 3 and then let's just make that work. 7, 8, 9. Let's put this as 9 up here. So here I am at 3, 9, and again an open circle. I would do maybe one more, like 4 squared is 16, which isn't going to show that well, but I'm just going to make it a point kind of high up here. and then I'm just going to connect those dots so I can see this jump between the pieces. Luckily, the homework you have only has you do multiple choice, which is nice. So I'm going to show you exactly what your homework looks like, and then you may have different numbers, but you'll have the same setup. So here's 3 pieces. I have x cubed when x is less than -2. I have -6 when x is greater than -2 but less than 9. And then I have the square root of x when x is greater than 9. What I first notice is everything is a strict inequality, which means open, open, open. I can immediately look at these graphs and get rid of a couple. See these closed dots? That tells me that's not the answer. So this is gone, this is gone. I know that can't be it. The other thing I see is, like, if I looked at x being less than -2 and think, well, let's just put in -2, -2 cubed would be -8. And when I look at this first graph, I see at -2, it's up at +8, and I say, let's get rid of that also. So this first page didn't give me any answers. So the second page, same function, but I'm just going to go through the choices again, and I see all these closed dots, which says, let's throw that out. And then I go back to that -2 cubed, which was -8, and this time I can see that works. I can see it's down when the numbers are less than -2. I can see the -6 from -2 to 9, and then I can see the numbers that correspond to the square root of x when x is greater than 9. This, through process of elimination and just kind of talking out what the different pieces should look like, would be our answer. So that's how your homework will be. They shouldn't be too bad. Just try to do a little plug and chug.